Hello, this is Itsu. Okay, trying to drive with DC 10 volt into the input coil. I modified something I had here. This was a MOSFET driver being driven by a 555 timer, but the frequency was too high, so I removed the 555 and only drive now the MOSFET driver and the MOSFET. Kind of this circuit. I have 10 volt via a automotive bulb for protection going to the input coil, which is 1 ohm, then going to the MOSFET, the RRF B260N, to ground. And I have the MOSFET driver, the UCC 37321. It's running on 12 volts from a separate power supply. Grounds are connected. There's a 10 ohm resistor between the driver and the MOSFET. And I drive the MOSFET driver with my function generator again to get the low frequency in the tens of hertz range. I monitor the function generator input, the red probe with the purple trace, so that's the input from the function generator. I have a blue probe measuring the gate of the signal of the MOSFET, and I have the yellow probe, which is a high voltage probe at the coil, the input coil. So I will measure at the drain of the MOSFET compared to ground. And we can see already we have the function generator set to 40 volts square wave, 50% duty cycle, 10 volts positive. Oops, and we can see that here in the purple trace, which is the input, DC only, 10 volts, and the blue trace is the gate signal on the MOSFET, so after the driver. So we have there something like 12 volts, 40 hertz, 50% duty cycle. I did not connect the drain yet. With the other scope, which is isolated from ground, I have the red probe across the 10 ohm resistor, measuring the output. Okay, I will now connect. So we have 12 volts on the MOSFET driver, and I have a separate 10 volts on the MOSFET, which I'm now going to connect. Makes a lot of noise. We can see the signal on the drain of the MOSFET at 30 Hz, which has a nasty spike, 250 volts. And this is the output signal from across the 10 ohm load resistor in the bucking coils. Frequency 40 Hz also, and 2.1 volts peak to peak. I can try to, not sure if you can hear me, I can try to increase. This is the signal on the drain of the so we are at 10 volts per division now, with a nasty spike and some ringing. I can increase the and we can see that the signal decreases, sorry, not decline. 900 millivolts now. Spikes are still we can see the amperage through the MOSFET. The clicking is the steps being taken by the function generator. But it goes down now again till we are now at 1 kilohertz. So I'm not sure if you want to know anything more in this setup, but this is the 10 volts DC square wave 50% duty cycle on the MOSFET feeding into the input coil. Okay, thank you for watching.